Hey guys, my name is Trevor Sullivan. I am a solutions architect with StratusGrid. StratusGrid is an AWS Premier Consulting partner, and we're also an independent software vendor, or ISV, that provides a FinOps tool known as Stratosphere. If you're interested in learning more about StratusGrid, then head out to our website here at stratusgrid.com and feel free to ask us for a demo of our FinOps tool called Stratosphere, which is, you can see right here. And this is a tool that helps you to optimize your AWS cloud spend across a large enterprise environment. It's also especially designed for private equity firms that need to manage the AWS spend and cost optimization across a large portfolio. Now, the topic for today's video is going to be around the Amazon Bedrock service. If you head out to our YouTube channel at youtube.com/goforthandcloud, then you can check out our channel. I'd encourage you to subscribe so you get notified about new videos. But the last video that we did was actually on the Amazon Bedrock prompt flow builder. So what the prompt flow builder is it's a visual node-based editor that runs directly inside of the AWS Management Console and allows you to create large language model based workflows. So, this is the announcement that came out back in the middle of 2024 that talks about this new feature that's coming out. There's actually two new features that kind of go hand in hand with each other. There's the prompt management feature that allows you to create and define prompts with certain input variables, placeholders inside of them. You can define those separately if you want to, and you don't have to use the prompt management feature if you don't want to. But then the other feature that we have is called the prompt flows feature. And the prompt flows feature has this thing called the prompt builder, and that's referring to that node-based visual GUI editor that we can use to actually create these complex workflows by invoking large language models, getting responses, extracting certain bits of data from those responses, sending it off to other tasks like Lambda functions or Amazon Lex chatbot integrations and things of that nature. So this is actually a really exciting feature that Amazon has announced, and it's really easy to use. So if you haven't already seen our first video that introduces that node-based editor, I'd encourage you to go out and watch this video that introduces just the fundamental concepts of using the prompt flow builder feature. Now, in this particular video, what we're going to be doing is expanding on that previous concept that we introduced, and we're going to be talking about how to invoke an AWS Lambda serverless function from one of your prompt flows that you build inside of this node-based editor. So this is the node-based editor here. They've got kind of this landing page here under the Amazon Bedrock marketing page. Basically, it just provides this node-based editor that you can see here. You can wire up different nodes to each other and have them execute in a certain order. You can have multiple outputs. You can call different language models depending on what your preference is. You can use like the Amazon Titan models. You can use the Claude models from Anthropic. And there's a bunch of different models that you can use. You can also use the Llama models. And all of these different models that are available in the Amazon Bedrock service are what are called foundation models. So these foundation models are just pre-trained models that have a very large kind of base intelligence in them. And then you can start to build custom integrations around these foundation models. Amazon Bedrock does also provide the ability to actually customize these foundation models by doing something known as fine tuning or continued pre training. Those are a couple of different ways that you can customize those foundation models. But when it comes to this prompt flow builder feature, we have the ability to just call those foundation models themselves. As far as I could tell from the interface, there didn't seem to be a way to choose a custom trained model at this point in time, but that might be something that they either add in the future or maybe it's hidden behind some certain UI elements that I'm just not aware of at this point. So if we head over to the documentation for the Amazon Bedrock service here, head down to the prompt flows for Amazon Bedrock section here. And then if you expand how it works and go to node types in prompt flow, this is actually going to show us all the different types of nodes or boxes that we can add to our workflow and wire up or connect to each other to build out an entire end-to-end workflow in the prompt flow feature. If we scroll down a little bit here and take a look at the node types, we have the input and output nodes. We already saw those in the first video where we introduced that. Those are just your entry point and exit point for the entire workflow. And when you create a new prompt flow, it's going to just automatically add those two nodes into your workflow so that you can just build on top of those. But where the real functionality comes from is when you start to add other types of nodes for handling data. So under nodes for handling data, we already took a look at the prompt node here, which allows us to invoke one of the large language models, one of the foundation models that are exposed through the Amazon Bedrock service. This is a managed service. You don't have to worry about deploying the LLMs. You don't have to manage any infrastructure or manage any Linux servers or anything of that nature. All that is abstracted for you. All you have to worry about is actually invoking those large language models, either through the API, or in this case, we're just going to be using the prompt flow feature to handle it for us. So we don't really have to write any code in order to use those models with this GUI editor. Now, the other type of node that we're going to be exploring here is called the Lambda function node. We do have some additional nodes here. If you want to use Bedrock agents, we actually have another video on our YouTube channel that talks about how to build custom agents with the Bedrock service. So feel free to check that out. That does also use Lambda integrations under the hood. But we also have a knowledge base node, and we have a couple videos on our video channel that talk about how to use retrieval augmented generation by communicating with a vector database in either PineCone or MongoDB Atlas or another vector database that's supported, such as the OpenSearch service from Amazon Web Services. So that's another option that you have for nodes that interact with data sets. We also have the ability to store and retrieve data from Amazon S3, but what we're going to be looking at today is this Lambda function node. What this allows us to do is somewhere inside of our prompt flow workflow that we're building inside of this GUI editor, we can simply drag and drop one of these Lambda function nodes and actually take some data from the workflow, process it in AWS Lambda, get some kind of data back from that Lambda function, and then continue to use that data that's been processed by the Lambda function somewhere inside of our workflow. So by using this Lambda integration, this opens up a whole world of integrations because our Lambda function code can communicate with external APIs, it can communicate with databases, it can access nodes on our VPC network in Amazon Web Services, and any other nodes that are connected to AWS using things like Direct Connect or VPN connections and things of that nature. So by having this ability to integrate with Lambda from these prompt flows in the Bedrock service, it just opens up a whole world of custom integrations that you can build or we can assist you with building as AWS experts. So this is the feature that we're going to be talking about today, is how to set this integration up. There are a couple of gotchas that we're going to take a look at as we set this up. And if you're not familiar with AWS as an ecosystem, if you're not familiar with Lambda on its own, also known as serverless functions, or if you're not familiar with Bedrock on its own, then some of this stuff can be a little bit intimidating, especially when you start to get into things like AWS IAM permissions and all the complexities that are kind of going on behind the scenes there. So my hope here is to kind of demystify these things for you so that you understand how this feature works and that you're able to set this up yourself and build custom integrations that are useful for your specific use case. So what we're going to be doing is heading over to the AWS Management Console here. I've already got the Amazon Bedrock service open here. So if you log into your AWS account, if you're following along, you just go up to the unified search bar here and just search for the Bedrock service. You can very easily just navigate to the Bedrock console. Now, these are the foundation models that I was talking about earlier. So we've got the Titan models from AWS, we've got the Claude models from Anthropic, we've got the Llama models that are open sourced from Meta, and there's several others available here as well, depending on your use case. Stable Diffusion is more of a text-to-image type of use case, but we do have some large language models available in here that we can call from prompt flow. And previously, we did use the Claude 3 Sonnet model, which is a pretty middle-of-the-road model for doing text generation inside of the Bedrock service. Now, what we're going to do is go down to Bedrock configurations here. If you're new to AWS and you have a brand new AWS account, you might have to go actually enable some of these models for usage inside of your account before you can actually consume these models. So if you go to Bedrock configurations on the far left nav and go to model access, you can go ahead and say modify model access right here. And then you can go through these checkboxes here and check off which of the models you want your account to have access to. By default, most of these models are probably disabled, so you won't have access to them. But all you have to do is come into the Manage Model Access area of the console, check off these boxes, and then hit this Next button right down here. And that will go ahead and activate the features or those models for your particular AWS account. And then after several minutes, you should see the status, the access status field here, update to show that you have access granted to those particular models in your AWS account. So keep that in mind. If for some reason you're unable to follow along with some of these steps, then you might just need to run down and do that. So we're going to go over to prompt flows right here. And previously, we looked at an example in our last video where we introduced the prompt flows feature here that generated a random name based on a country. If we just really quickly take a look at this example here, the only type of node that we added into this particular example was the prompt node here. So we generated a list of first names based on a placeholder country. So that's a variable input that we can feed into the flow input when we invoke this particular flow. And then we also take that same country as input, and then we generated a list of last names. And then finally, we took the list of first and last names that we generate, and then we select a random first and a random last name, and then we mash them together with a static hard-coded middle name. I think I put Brett in there as a middle name, and we ultimately get a result. So if you recall from that video, we were able to go over here and say something like French. It'll generate a random list of first names and last names that are French, and then it'll give us a full name like Elise Rousseau, which is definitely very French sounding to me. And so this was a really simple example of how to combine multiple steps together and create placeholders or variables inside of our prompts here and get some kind of final interesting result. But what we're going to do differently is actually use the Lambda code node type here. And this is going to allow us to call out to the Lambda service, which is totally separate here. So if we search for Lambda in the unified search box, we can go out to the Lambda console here, and we are able to just define a serverless function here in a variety of different languages. So we could use JavaScript, we could use C#, we could use Java, we could use Python, and a whole bunch of other supported languages. And what we can do is generate some custom code that we're going to run inside of the Lambda function, and then invoke this Lambda function from the prompt flow that we are creating right over here. So we're going to create a brand new example from scratch to show how exactly this works. So what we're going to do instead of just generating some random names here is we're going to go back to prompt flows, and we're going to create a brand new prompt flow here. And what we're going to do is pretend that our use case is to benchmark different code samples. So I basically want to feed in a task like go create 1,000 text files, or sleep for 10 seconds, or just whatever code it is that you want to run. And I want to basically declare that in a natural language input what the task is, and then I want the Lambda service to actually go out and run that task and kind of measure how long it takes for that particular task to run. So that gives me the ability to just say, hey, how long does it take a Lambda function to execute the create file operation if I iterate across 10,000 files? Maybe I want to test file system performance, or maybe I want to benchmark database performance against a MySQL database or something of that nature. So rather than having to actually code all of that Python code by hand, we're going to set up a Lambda function that can dynamically execute code that we can feed in that's generated from a large language model prompt instead. What I'm going to call this is Trevor Python benchmark. Actually, I'm going to call it Trevor code benchmark, because what I want to show you is how we can actually create a flow where we can define a task, but we can actually generate code in multiple different languages so that theoretically, and we're not going to implement all of this, but we are going to at least implement the concept so you can kind of extrapolate on that. But what I want to show you is how we can take a task like create 10,000 files in the file system that are 1 megabyte in size each. And we could generate that code in Python. We could generate that code in JavaScript. We could generate it in other languages like PowerShell, for example. And then we could theoretically dynamically execute all that code inside of a Lambda function and then determine which of them is fastest at that particular task. So we're going to call it Trevor Code Benchmark just to be a little bit more generic here. And we'll give it a description like benchmarks, code samples generated from an LLM. And then we're just going to create a new IAM identity. So this is an IAM role that gets created and bound to this prompt flow so that any permissions that we need to any external services, such as Lambda in this case, will be granted by this particular application identity in the AWS IAM service. All right, so let's hit the create button and let's start building out some of this prompt flow. What we're going to do in the prompt flow editor here, so we always start out with our beginning and end right here. So we've got the flow input, flow output, typically put those on the left and right here. And then what we're going to do for starters is bring in one of our prompt nodes here to generate some code. Now remember that the prompt node does not have any input identified as a default. We actually have to create some placeholders by using the double curly braces around the variable name. So for example, what we could do is just give this a name so that it's relevant, like gen code Python. And then again, we're not going to be using the prompt management feature. We're just going to hard code our prompts here. So I'm going to say define the prompt in the node itself, and then we'll choose a model. I typically just stick with the Claude models here because they work pretty well. I'll just use the Sonnet model. And then in the message here that we want to feed to the LLM, I want to say generate a Python code snippet that X, right? And then that's going to be our placeholder, which is task. So generate a Python code snippet that whatever, right? So we could say, creates 10,000 files in the /temp directory, which is the scratch directory for a Lambda function, or connects to a database and creates 10,000 records in the employees table or something like that, right? So what I want to do though, is if I just say generate a Python code snippet that task, then the large language model is typically going to generate that code snippet, but it's also going to generate a summary before the code snippet and say, hey, I see that you want to generate this task and blah, 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 right? Well, we don't want all that extra text. And we also don't want any additional special characters because whatever code gets generated by this large language model prompt is going to be directly fed into the Lambda function. So we can't have any extra characters that aren't actually Python code that we are generating. So what I want to do is say, do not include any extra text. Do not include any backtick characters. And the reason that we do that is because oftentimes, if you've ever generated a code sample from something like ChatGPT or other types of LLMs out there, you'll probably see that some of the code snippets are surrounded in backtick characters, triple backticks. And what that is, it's markdown syntax that interprets that particular section as an actual code sample and applies syntax highlighting typically, or at least it formats it as a monospace font like code would typically be in a text editor. And so we don't want those extra characters. We don't want those backticks that are interpreted as markdown, not actual programming code. So now that we've got this prompt created here, now you can see that we've got this task placeholder. And now what I can do is just feed whatever input we pass into the prompt flow into that particular prompt. And then for now, I'm just going to hook up the output over to the flow output right here, just so that we can test this out really quickly to make sure that it's working the way that we expect it to. So I don't think we really need to do anything else here at this point. Let's go ahead and just save this really quickly. We'll look for that green message to make sure everything got parsed successfully up top. And then we'll open up the right-hand sidebar here and we'll say create 10 text files in the /temp directory. And we'll see what that does really quick here. And so it imports the OS module for Python. It creates a for loop with 10 iterations. It defines a variable with a file name, and then it creates a context with the file handle, and then it just doesn't write anything to the file. So it's essentially just creating an empty text file with a dynamic name with the iteration as a suffix on the file name there. So that's a pretty typical code sample. And as you can see, there is no extra text. There's no backtick characters, there's no summary, there's no conclusion at the end or anything like that. It literally just spit out the exact code sample. Something else that I might test here would be just as kind of an artificial test, like say sleep for 5,500 milliseconds. And so now you can see it says import time module for Python, and then we call the time.sleep function for 5.5 seconds. So that's a pretty typical output that we would expect. Maybe we could test something else out, like let's say create 5 text files in /temp directory that are 1 megabyte in size. See what we get there. Typically, this is going to use the random module here, and it's just going to grab some random characters here and write that to the file. So that looks pretty reasonable there. We don't have any extra text or any special characters there. We literally just have the Python code sample. So now that we've got this part working, the next thing that we want to do is actually implement the Lambda function that is going to dynamically execute these code samples so that we can determine the performance of that code sample that gets fed in. So, is it faster to create 10 text files that are 5 kilobytes in size, or does it take longer to write 100 files that are 1 megabyte in size? And then I could say, well, based on different types of storage that maybe I mount to my Lambda function, like external storage with EFS file systems versus the temporary scratch space that the Lambda function has, is there a difference in performance? Or again, the Lambda function could connect out to external resources like MySQL databases or something like that, and we could, kind of go from there. Those are more complex use cases because you'd have to feed in credentials and things like that. But you kind of get the picture here that we're able to generate a dynamic code sample based on a task that we're feeding in as natural language, and then we're executing it dynamically. All right, so what we're going to do is go back to nodes, and we're going to bring in a Lambda function. And we have not yet created the Lambda function itself. So what we want to do is just kind of position things here. If we open up the Lambda service here, you can see we have a list of functions that are already defined. So one of the first things that we'll want to do is to actually go over to the Lambda service and create that function. So I'm going to create a function here called Trevor-sg-python exec. We're going to choose the runtime. So we're just going to choose the latest version of Python here. And then we'll just say create function. Now, from a security model here, I did just want to mention that when you talk about dynamic code execution, there is a lot of security concern around that type of thing. And the way that we're going to be setting up this Lambda function is that only the specific prompt flow that we're creating right over here that has this particular name is going to actually have access to invoke this Lambda function. So we're not just opening up access for anybody to be able to exec this Lambda function. We're only going to allow it from this specific prompt flow in the Bedrock service. So from a security model perspective, we are being very granular with the permissions that we're granting. And by default, the Bedrock service won't actually even have access to invoke the Lambda function until we grant it that access. And we'll see kind of how that works right here. Down in the body of our function here, one of the first things that I like to do when I'm building out one of these Lambda function handlers that integrates with some external service, like the Bedrock prompt flows feature, is I like to just print out the input event. So the Bedrock service, just like many other services, whether it's S3 object events or something of that nature, are going to feed in some kind of payload, some kind of input event that has a bunch of data about what occurred in that external service that feeds into the Lambda function execution. So what I like to typically do is just come in here and say print the event. And then typically that's going to print it out in a Python syntax, like a Python object syntax. So because the JSON module is already imported here, we'll just say json.dump s to dump that Python object. as a string so that we can actually see the JSON representation of that object, and we can figure out how to parse specific fields out of that payload and actually use that payload inside of our Lambda function. Now, on the return value here, you can see that the default return value of the Lambda function code is a Python object. But I'm going to show you why that's actually an issue momentarily here. Also, one thing you want to pay attention to is that anytime you make any code changes to your Lambda function that is the handler for your prompt flows, you got to click on the deploy button to deploy those changes so that the Lambda runtime knows about those code changes. And the next time that you invoke this Lambda function, the Lambda service is aware that it has the updated code. So just keep that in mind as well. Now that we've created this Trevor SG Python exec function here, we can go ahead and call it from our prompt flow here. So let's go ahead and go to the Lambda service here. We'll probably have to pull in a new node here or refresh the screen. So if we go to nodes and then say Lambda function, let's do a search for there's Trevor SG Python exec. So what we're going to do now is move that up here. We're going to disconnect this right here. And what we're going to do is say, I want to take the code sample that's generated from this prompt right here, and I actually want to feed that into the Lambda function. I'm going to give this Lambda function a name like Python executor, for example. And, what we could do here after we generate some Python code, we could also have another node just to give you some ideas for extrapolation in the future. We could have another prompt that has the same task here as input. But what we're going to do, I didn't mean to connect that over there. So what we want to do in this prompt down here is say, hey, maybe I want to test some other language. Like let's do gen code JavaScript, right? And so then what I could do is say, define this in the node, choose the Claude 3 Sonnet model here, paste in that, and say, instead of generating a Python code snippet, generate a JavaScript code snippet. And I could get more specific, like I want this to be ES6, or I want this to be, compatible with whatever version of JavaScript language that I want to. But the idea here is that we can take this natural language task that we enter as input and then feed it into a couple of different nodes that generate multiple different code samples that we could then feed into different Lambda functions to execute different runtimes. So one Lambda function could execute some Python code to benchmark in there. Another Lambda function could benchmark some JavaScript code, and we could kind of compare performance by just feeding tasks in using natural language input. So for now, I'll just go ahead and put in a flow output here and just call it output JavaScript code. And we'll just take the generated code and spit it out there because we can have multiple outputs. But then for the Lambda function here, you can see that the output or function response is a string type. And we'll take that and feed it into the flow output here. And let's click on save. Let's make sure that everything works here. So it parsed properly. We get the green bar there. That looks good. What you're going to see is that the policies on the application identity, the IAM role that was automatically created when we created this prompt flow, was updated so that it has permission to the Lambda service. However, there is something called a resource-based policy in the Lambda service that limits who can actually invoke the Lambda function. So even though the IAM policy for this identity has been granted access to the Lambda service, there's an additional resource-based check that has to be performed every time that we authenticate to the Lambda service to determine whether this prompt flow has permission to actually invoke this Lambda function or not. So what we're going to do is just say save, which we already did, and then we're going to open the sidebar here and plug in a task like generate 10 text files in the /temp directory, and we should get an error here that says access denied while invoking Lambda function. Check the permissions on the Lambda function and retry the request. And I actually expected that to happen because the prompt flow does not have that resource-based policy. So what we need to do is first get the ARN of the prompt flow itself. So I'm going to middle click on prompt flows in this breadcrumb interface right up here. And then what we're going to do is open that up right over here. And what we can do is in the Bedrock console here, click on the prompt flow that we created. and then you'll see the prompt flow ARN. This is the Amazon resource name that contains the service, the partition, which is like AWS or AWS GovCloud or AWS China, that kind of thing. It also includes the region. It includes the 12-digit AWS account ID. It also includes the specific resource type, which in this case is a Bedrock service flow resource type. And then it has the unique identifier, which in this case is a kind of randomly generated internal identifier rather than the actual name of the prompt flow. So the ARN for the prompt flow is actually based on its random identifier, not the actual name of the resource. So don't get those confused, but you can actually see the ID is right here, and that becomes part of the ARN. So what we want to do is copy that ARN to our clipboard. We can close this window and come back to the Lambda console. And then what we're going to do is go to configuration and go down to permissions. And if you scroll down in the Lambda function permissions, you can see we've got these resource-based policy statements here. Now, what we need to do in order for the Lambda service to allow the Bedrock service to invoke this specific function, we have to add a policy statement to this specific Lambda function that grants an AWS service access to invoke it. So the service is Bedrock, but you're going to see that Bedrock is not in the list of services here. It just doesn't show up in this list at all. So what we have to do is say other, plug in a unique statement ID. I'll just call this Trevor999. Doesn't really matter what that is. Then for the principal here, the principal is going to be bedrock.amazonaws.com. So that is the identifier for the entire Bedrock service. And then we have the source ARN. What is the Amazon resource name of the specific resource in the Bedrock service that we want to allow to invoke this specific Lambda function? So all we have to do is paste in the ARN of that prompt flow that we created. And now when we choose action, Lambda, invoke function, now we're saying that this specific prompt flow in our account in this region, US West 2, from the Bedrock service with this identifier has access to invoke the function that we specified here. So when we save this resource-based policy on the Lambda function, that will now grant that access. If we come back to this window here and then try to run it again, let's just copy this prompt that we plugged in here before and then paste it in and click on run. We're going to probably get a different error message here. And the reason for that, you can see it says unable to convert node output function response of node Python executor to type string. So if you break this down into pieces, don't let this kind of confuse you. So if we take a look at the node called Python executor, that's the Lambda function node right here. And it's talking about a node output, right? Well, which output? Well, it's the output of type of name function response that has a type of string. And what's happening is it's trying to take, if we look at our code here in the Lambda function, it's trying to take this object that's being returned and it's trying to parse it essentially as JSON, right? And so that's not going to work because it's expecting there to be a string instead. So what I typically do here is just kind of comment this out for starters and then just return a string. Let's actually do a return statement, not a print statement. So let's say return the result from my Lambda function is blah. And then, we can always come back in here and change this later on if we want to. But for now, I'm just going to put in a dummy placeholder. So let's click on the deploy button to deploy those code changes to our Lambda function here. And then we'll come back to the Bedrock service here. And let's go ahead and try to run this again. So let's copy our prompt, plug it in. And this time we should just get that generic response, right? So the result for my Lambda function is blah. Now, what you're also going to notice here is that because we added a second output down here that gets the generated JavaScript code, it's actually showing us what the generated JavaScript code is right here. Something else I like to do for debugging purposes is to just add another output node here. And so rather than just taking the Python code that gets generated and feeding it into the Lambda function, I want to be able to debug whatever the generated Python code is. So I'll just feed that into another output node here so that we can see the generated JavaScript code, the generated Python code, and the actual output from the Lambda function that executes our code sample. So let's give this a name like output Python code. And let's go ahead and save these changes. Click on the save button, make sure that everything parses out properly. We should get that green bar. Perfect. There we go. Let's just test it one more time to make sure nothing has broken here, and click on run and see what we get back. And then we'll go ahead and edit our Lambda function code. All right, so there's our Python code output for debugging. There's our JavaScript code output for debugging. And then here's the actual output from executing the Lambda function. Okay, so at this point, we have gone through the setup steps that are necessary to get the Lambda function actually working. So we are successfully executing the Lambda function. But now what we need to do is to take the code that's being generated right here and dynamically execute it. So how do we do that? Well, let's come back to our Lambda function code here. And remember, we added this line right here on line number 5 that says json.dumps event. And so what we're doing is we're taking that input payload that's being fed from the prompt flow feature that's being fed into the Lambda function when it's being executed, and it is just dumping it out as JSON. Now, where does that go? Well, the Lambda service actually integrates with the Amazon CloudWatch logs service separately. That's a totally separate service. It's part of the CloudWatch service rather than the Lambda service, but they integrate together very nicely so that the CloudWatch logs service captures the output from your Lambda functions. If you scroll down and actually go to the monitor tab right here, click on view CloudWatch logs here. That'll take us straight over to what's called a CloudWatch log group. That's kind of the root level resource in CloudWatch logs that we have for logging from the Lambda service or any other service. So it should have taken us straight over to the log group for this specific Lambda function. Let's just try opening it up again here. Sure enough, there is the log group that we are expecting. Now, remember that in CloudWatch logs, each log group has multiple log streams. You can see I have 2 different log streams here, and every time that we deploy a change to our Lambda function code, it's going to deploy a new iteration of that lightweight Lambda container that's running in the background in the AWS infrastructure. And so that's going to generate a brand new named log stream inside of the same CloudWatch log group. So anytime that you hit that deploy button and update your Lambda function code, or if your Lambda function goes cold after a period of time, and then it starts up a new instance of your Lambda function, if you maybe leave it offline and don't touch that Lambda function for maybe 12 hours and then come back later and invoke the prompt flow again, that triggers your Lambda function, then you're probably going to see a new log stream show up in this list here. So you always want to be looking at the latest log stream to make sure that you're seeing the latest log entries from that Lambda function. Okay, so if we open up the log stream here, our latest one, you can see we have a couple of executions here. And if we look for this line right here, where you can see we've got this object, this JSON object right here, you can actually see that this is the payload. This is the event payload that is being fed from the Bedrock prompt flow feature into the Lambda function. So we have this outer object here, denoted by the curly braces. That's a JSON object. Then we have a property called node, which is an object. Then that object has a inputs property, which is an array of objects, but we only have one object in that array, so we would index into it as the 0th or first element of that array. And then this child object inside of that array has a property called value. And that value property is actually a string representation of the code that was generated by the large language model. So this string that we're seeing in this value property right here is exactly the same code that we saw outputted from the prompt flow that we tested right over here. I guess the output disappeared, but you could previously see that code sample being generated. So what we need to do is capture the string from this value property in our Lambda function code so that we can tell our Python function to dynamically execute this code. And we can do that by using the built-in exec function in the Python language. So what we're going to do is head back over to the code tab of our Lambda function here. And inside of our Lambda function handler, let's just clean up that comment there. All we're going to do is create a variable called code, and then we're going to drill into this event. And so we're going to grab the event, and then we're going to go into the top level node property. At least I think that's what it was. Let's go ahead and double check. So it's node, and then we're going to grab inputs, property, and then we're going to index into that array. So let's say inputs, and then we're going to index into the first 0th element of that array, and then we're going to grab the value property. And so whatever the string is that's returned by going to that value property is going to be assigned to code right here. So as an additional debugging step, I'm just going to print out that code snippet to the logs so we can capture that code variable and actually validate that it's being parsed correctly inside of our Lambda function code. So now that we've got that, the last thing we need to do is to actually execute the code as a string. So all we do is we say exec and then pass in that code string. And that's how we do dynamic code execution in our Lambda function based off the code snippet that we're generating dynamically from a LLM in the prompt flow based on the task that we actually feed into it. Okay, so let's go ahead and deploy these code changes and let's test things out to see how it works. And we're going to want to keep the CloudWatch logs window open here. I'm going to head back up to the log group level here. And we still only have 2 log streams because we have not yet executed our Lambda function again. But as soon as we reinvoke our prompt flow and that reinvokes the Lambda function, then it's going to end up spawning the Lambda function and another log stream is going to get created because we made code changes to our Lambda function code. Let's come back to the Bedrock console here. And we are just going to go down to the prompt flow and we're going to say generate 10 text files in the temp directory. Okay. So that's going to go through, it's going to generate Python code, it's going to generate some JavaScript code, it's going to spit out both of those as debug outputs, it's going to run our Python Lambda function, and then it's going to spit out the final result. Now, the final result from the Lambda function is always just going to be this static entry here. We could make this more dynamic by actually timing the execution time of the code snippet, but for now, I'm just leaving that static, but at least this does validate that the Lambda function executed successfully and passed execution to the next node inside of our prompt flow here. So it's kind of a nice debugging step because it just shows that the Lambda function did complete successfully execution. And as you can see, we did get that output there. So let's come back to our CloudWatch logs here and refresh our log streams. And as you can see, sure enough, we do have a third log stream. Typically, the newest one is on the top. So let's open that up. And as you can see, we have that payload from the event input here that we dumped out as a JSON string. And then down here, we have a multi-line code sample that represents the code snippet that was generated. So we imported the OS module. We said for I in range 10, we have 10 iterations. We declare a file name variable. We open up a context with the file handle. We write an empty string into that file. And then that's the end of our code sample, right? So it did exactly what we asked it to, but we didn't actually have to write this code here. We just asked it to do a task, and then the LLM generated the code sample for us in 2 different languages, could be 3, could be 4, right? We could generate as many different code samples as we wanted to in different languages that have, compatibility with different versions and any additional parameters or constraints that we wanted to assign to those generated code samples. But in this particular case, it just happens to be a simple Python code sample. All right, so we have validated that things are working properly here. And what you're going to notice is that at the very end here, we get this final report from Lambda that says, all right, what was the duration? So it took 20 milliseconds to generate 10 text files in the /temp scratch directory. If we didn't tell it to put it in the scratch temp directory, because Lambda has a read-only file system, we would actually get an access denied error thrown when the Lambda function executed. But because we're telling it to write those text files into the /temp directory, it is actually successful. Okay, so it took about 20 milliseconds to generate 10 files. Well, how long would it take to generate 1,000 files? Well, I don't know. Let's find out. So all we do is we add the same task and we just increase the number of iterations that we want it to do. We go ahead and rerun our prompt flow here. And you can see the code sample that's generated is a little bit different here. So all it does is it increases the number of iterations, but it looks essentially the same. So if we come back to the CloudWatch logs here, and sometimes there's a little bit of a delay here, so just try to be a little bit patient with it. But if you keep scrolling down towards the bottom, we should eventually see some new events scroll in right here. And so now, if we open up that final report, you can see that the duration was 444 milliseconds. So it took 20 milliseconds to generate 10 files. It took 444 milliseconds to generate 1,000 files. So those text files are just empty though, because they just have an empty string as the contents of the actual file. So what if we actually created some random text files that are a megabyte in size each? Well, that's obviously going to add some execution time, right? And we're going to run into another little gotcha right here in just a moment. So let's go ahead and prompt again, say generate 100 text files in the /temp directory that are 1 megabyte in size. So now we're adding this size constraint and saying, I want you to create a bunch of files, but I want each of those files to be 1 megabyte in size. I don't want them to just be empty. So now you can see it actually generated a function here that generates kind of a random string, and then it calls that function and writes that data into each of those files. So if we come back to our CloudWatch logs here, again, we did not make any changes to our Lambda function code. All we're doing is feeding a different code snippet and then dynamically executing that code. And so down here, it looks like we actually had a code error here saying that the name random is not defined. Now, to me, this looks like a potential bug in the code that was generated here. So let's go ahead and take a look at the code that was actually generated right over here. And it looks like some kind of error actually occurred in our execution here. And this is showing up in the prompt flow output because the Lambda function actually threw an exception, right? So if we take a look at the logs, we actually had an error occur during the execution of our Lambda function. So because the Lambda function never actually returned the final result, the error shows up right here that says this dependent Lambda function inside of the prompt flow failed to process. So let's take a look at the code that we have right here. And it looks like we had an issue where the random module was not properly identified. And I'm not really sure why that's occurring here. To me, on the outset, this kind of looks like a valid code sample. So all I'm going to do is just try to copy this and run it again and see if we get a slightly different code sample that gets generated dynamically and see if it just uses a different approach to coding up that example. So this looks a little bit more similar to what I've seen before. Let's also make sure that it's not prompting for user input. I've also seen something where sometimes the LLM actually generates some code that ends up prompting for user input. So one of the things I'm going to add to the Python gen code prompt right here is to say, do not prompt the user for any input. And so let's just add that in there. And we'll go ahead and save this flow. Once again, we're not making any changes to the Lambda function. All we're doing is just changing how the code is getting generated as part of this flow right here. So let's go ahead and paste in this prompt right here again and run it and see what code sample gets generated this time. All right, looks like that is pretty similar to what we saw before. So it looks like there's just some kind of error happening here. So let me change the prompt a little bit and see if we can get something different. Instead of saying that are 1 megabyte in size, I'm just going to say generate 100 text files that are 1 megabyte in the /temp directory and just play around with the prompt a little bit and see if we get a slightly different code output here. And so if we take a look at this code sample right here, once again, it looks like it is still using that same approach here, and it's just continually failing to execute here. So what I'm going to do is say, make sure the code sample is compatible with Python version 3, just as an additional check. Since we do have the potential to run Python version 2, we want to make sure that it's not actually doing that. Let's go ahead and save that change to our prompt flow here as well. Make sure everything parses out properly. And then we'll come back in here and try this prompt again. And we'll just kind of keep iterating here and see if we can get the LLM to generate code that's actually going to work properly here. So we're still getting an error here. It's still using that same approach. So I'm just going to remove the word snippet there and say generate a Python code, generate some Python code that task. And then if I just kind of read this here, that generates 100 text files that are 100 megabytes in size in the temp directory. I'm just going to keep making some kind of minor tweaks to my prompt right here. Let's go ahead and run this again. And it looks like we're still getting that same error message here. So let's go ahead and inspect our CloudWatch logs again. And we should still be inside the same log stream here since we still haven't made any changes to our Python code in the Lambda function. So let's just go ahead and take a look at this sample code and see if there's any issues here. So it looks like on this latest iteration, I don't actually see any errors occurring inside of the Lambda function. So let's just make sure that there's not a newer log stream in our log group. I'll go back to the log group level here, just refresh my log stream, and I want to make sure that I'm looking at the very latest events right here. So I don't actually see any exceptions occurring right here in my Lambda function code, and it does look like now that it's succeeding here, if we open up the final report, what you can actually see is that the duration is exactly 3000 milliseconds. And this is actually the issue that I was expecting to run into before, where we have a status of timeout. So essentially what's happening here is that our Lambda function has a default timeout. Anytime that you create a new Lambda function, the default timeout setting is actually 3 seconds. And so if your code takes more than 3 seconds to execute, then it's going to time out and the Lambda service is going to kill off the Lambda execution. And that's just to kind of control billing costs. It's to make sure that your code is performant and that any errors in your code are being properly handled rather than just infinitely consuming CPU and memory resources, right? So now that we've kind of figured out how to fix our prompt so that the code sample actually works properly, now we're running into this timeout issue where our Lambda function is getting terminated. And so all we need to do is say, okay, well, creating 100 text files, 1 megabyte in size, is clearly taking more than 3 seconds. So what we'll do is come back to our configuration for the Lambda function. We'll head over to the configuration tab and go to general configuration. And if we hit edit right here, we can actually customize the timeout here. So rather than giving it only 3 seconds to execute, we can go anywhere up to 15 minutes of execution time. So I'm going to say, well, we'll give you up to 20 seconds to execute. So if it still takes more than 20 seconds, then yeah, go ahead and kill it off. But I think generating 100 text files that are 1 megabyte in size should be easy enough. So let's go ahead and just save the Lambda function. And now that we've changed the configuration of the Lambda function, we're probably going to see a new log stream get generated. So let's come back up to the log group level in CloudWatch logs, refresh our log streams. And because we haven't executed it again, we're still going to be having 3 log streams. So let's go over and kick things off. Let's come down to our prompt right here and paste in our prompt once again and click on run. So the reason we were getting this error dependency resource failed to process was because there wasn't actually a code issue in some of these follow-up iterations where after we fixed our prompt right here, it was actually that it was timing out. So it's kind of a generic error message that you have to figure out, is it actually an error that's occurring in the Lambda function, or is it timing out, or is something else preventing that Lambda function from completing successfully and returning the final result? And so if we scroll down here, it looks like we are still getting that error. So let's go ahead and come back to CloudWatch logs to do some debugging. We'll refresh our log streams, and sure enough, we get a brand new log stream here. And it looks like we're running back into this error where it says that random is not defined. So I'm a little bit confused why it's deciding to do that with my prompts here. It hasn't always been that way based on my previous experience with it. Let's go ahead and just make some very minor changes to our prompt here and see if we can get it to generate some code that actually works properly. So let's try it with an extra comma there just to tell it what the size is. And let's see what we get back here. And there's our Python code. And if we scroll down, it looks like we got an error once again right here. So let's go ahead and scroll down in our CloudWatch logs right here and see if we are getting the same error with that random module. And it looks like we're actually timing out this time. So previously we got the random error, which is really weird because we are actually importing the random module right up here. But regardless, you can see that this time it didn't give us that error. It actually timed out again at 20 seconds of execution time. So what I'm going to do is just come back to the Lambda function and we'll bump up that timeout period a little bit more. Let's maybe give it 40 seconds to execute here. Go ahead and save that change to our Lambda function code, which is once again going to create a new log stream. So let's go ahead and prompt it once again and say run. And hopefully we'll get a pretty substantially similar code sample right here. And it looks like we're still getting an error here. So let's go ahead and refresh, and we should have a new 5th log stream here. Let's open that up, and we're back to having this same random issue again. And so let's go ahead and just say generate 100 random files in the /temp directory that are 1 megabyte in size. I'm going to say random files instead of random text files, just to see if that changes things up a little bit here. Let's go ahead and generate that code, and we'll come back to our log stream and check out what that produces. And so this time, it looks like it actually executed successfully here. So this time, it set a file size, it sent what the temp directory is here, it created an iterator over 100 items here, and it just randomly generated 1 megabyte files here. So if we come back over to our log stream and click on resume right here, then scroll down, it looks like the execution time was somewhere around 6.5 seconds. So I'm not sure why we were running into the execution timeout earlier at 20 seconds. For some reason, maybe that was based on the text generation that was being done rather than just using kind of random byte data. But for whatever reason, we were able to kind of fix that code issue and actually test this out. So now we could just start iterating on this a little bit and say, hey, generate 15 random files in the temp directory. Go ahead and execute that and just kind of compare performance between this and other types of code samples. All right, so we got a successful output there. Let's check out our logs here once again and take a look at the duration in those latest logs as soon as it finishes refreshing right here. And so now if we take a look at the duration, it looks like it only took 826 milliseconds. So what if we said, all right, it took 826 milliseconds to write 15 files with 1 megabyte of data. Well, what if I did that same thing with 15 random files, but they're 5 megabytes in size each instead? Let's go ahead and generate that code sample here. We should get something substantially similar once again, and we're just kind of comparing performance of the function. So we got a successful output there, so we know that the Lambda function completed successfully. And again, if we come back to CloudWatch logs and refresh our logs right here, that duration took about 4 seconds instead of 826 milliseconds. So, this just kind of allows us to play around with different code samples here. If we wanted to try something entirely different, we could do something like sleep for 3.3 seconds and generate a code sample there. So rather than actually doing some work like generating some random file data, instead we're just doing something really contrived, like sleeping for a little bit here. And you can see that we now got some output here. And if we take a look at the latest execution here, let's scroll down. This is the execution from generating some random data. Here is the execution from sleeping. And literally, it took about 3.3 seconds to execute here with just about 4 milliseconds of additional overhead. So hopefully this gives you some insight into how you can use the Amazon Bedrock prompt flow feature to call out to code that's running inside of AWS Lambda, serverless functions, and then how you can actually generate random code samples using an LLM and then feed those code samples into a dynamically executing Lambda function. So I don't have to update the Lambda function code to test out a code sample. All I have to do is generate the sample with an LLM, get the output, and then execute it in that same Lambda function that we've already set up. So make sure that you play around with this. Make sure you understand how the permissioning system works, especially with the resource-based policy. Check your Lambda function timeouts to make sure that you're not timing out and limiting performance of your prompt flow as well. And just play around with this feature a little bit and see what kind of interesting use cases you can come up with in order to kind of build some custom solutions around this exciting new prompt flow feature. I hope you learned something new from this video. Thanks so much for watching, and we'll see you in the next video. Take care.